Alright, so before we jump into our notes, I want to talk about what a sequence is. Now, a sequence is usually a list of things in order. It's in order from, this case, it's going to be least to greatest. Alright, and so a sequence usually has a pattern that it follows to get from each term to each term. Now, when we're dealing with sequences, what's important to remember is position, meaning which number does a sequence start with, and then what's the next number after that, and the next number after that. And so the way we have a specific notation that we use to identify that, which is what I want to get over and talk about. Alright, so here's how we talk about position in regards to a sequence. So if I'm talking about the very first number, I'm going to call it a sub 1. So a sub 1. Now the second number in this sequence, we're going to call it a sub 2. The third number in this sequence, we're going to call it a sub 3. So we're just using this letter A, and then we're putting this little sub in this sub number down here, right? So this means the first number, second number, third number, fourth, fifth, and sixth. Oops, that should be 6. And this is position. That's all we're talking about is position. So in this case, if I was to ask you, what is a sub 1? What number is a sub 1? You would write 2, right? So here's the first number. So you're asking me for the first number. What is the first number in the sequence? You would say 2. So right here, I would say, what is a sub 5? A sub 5. So you would figure out what is the fifth number in this sequence if I hadn't labeled it as like this right here. If I hadn't labeled it, you would look for the fifth number in this sequence. You would sort of count 1, 2, 3, 4, 5. So the fifth number in the sequence would be 22. All right. Now again, the reason why we do this right here. We do this to just basically identify the position in the sequence, Now in this case, let's go ahead and label these down here and then figure out it's certain positions that I've listed. Alright, so here I've already listed it. We know the first term in my sequence, the very first number is going to be called a sub 1, right? And then the second term is going to be called a sub 2. Then we have a sub 3, a sub 4, a sub 5, and a sub 6. So if I was to ask you what is a sub 2 equal to, you would figure out, well, that's a 9, so that's what 9 is. So I'm going to find out what is the second position in my sequence. In this case, what is the sixth position in my sequence? You would count, right? Here's 1, 2, 3, 4, 5, 6. So in this case, my sixth number in this sequence would be 729. So I just want you guys to familiarize yourself with this type of notation because we're going to bring that up next lesson. So in this case, we're dealing with position. And then let's go ahead and find our patterns for both of these. My pattern for this top one here, I'm going from here to here. So the first one, I can see that it's adding 5. From 7 to 12, I'm also adding 5. Here, I'm adding 5. See if it continues, I'm also adding 5. And from here to here, I'm adding 5. Okay, so I'm jumping 5 each time, so that is the pattern there. Now from here to here, let's see, I multiplied times 3. Now from here to here, 9 times 3 is also 27. So this looks like it's repeating times 3. So the pattern here is multiplication of times 3. Alright, so the difference between here is addition and multiplication. And then we identify that a sub 6 is basically just saying what is the sixth position in my sequence, or if I say a sub 2, what is the second position in my sequence? What's the second number that's listed? Alright, let's go ahead and jump to the note. So it says look at the sequence below, what do you notice? So here's we have one sequence here, we have another sequence here. Remember, I went ahead and listed a sub 1, a sub 2, a sub 3. This one goes to a sub 6, and we have this continuation, which means dot dot dot. And this is a sub 1 to a sub 5 dot dot dot, so it continues. Now remember, a sub 1 is just my position. What's my first number in the sequence, and then same over here. So let's go ahead and find the pattern really quickly. If I look from 6 to 8, I think it looks like it's just adding 2. From 8 to 10 is also adding 2. From here to here is adding 2. I think the pattern just continues. We're adding 2 twice. Alright, so plus 2 and plus 2. Alright, and then let's look from here to here. looks like I could be, let's see, adding 6 or multiplying times 2. So if I say add 6 here, does this pattern continue? Add 6? It does not, because then I would be at 18. So I think let's try multiply times 2 to see if the pattern continues. Alright, so if I say multiply times 2 is 12. 12 times 2 is also 24. 48 times 2, yep. And this pattern is times 2. Alright, so let's go ahead and read this definition. Alright, arithmetic sequence, a sequence of numbers in which each term is equal to the previous term plus a constant. The constant is called the common difference. So to find the common difference, and this is right here, what we've listed here is a common difference, right? It's the new term minus the previous term. So if we're looking at this one here, it'd be the new term. So if I was talking about the position a2, a sub 2, we would take the new term 8, subtract it from the previous term 6, so the common difference would be 2. In this case, I would take 10, subtract it from the previous term 8, my common difference would be 2, and the pattern continues. 12 minus 10 is 2, 14 minus 12 is 2, 16 minus 14 is 2. Now this one has a common difference. However, this one does not have a common difference, so this is not going to be considered an arithmetic sequence. This is. So this is how I label it. My common difference, d, is equal to 2, consider in regards to this sequence. Alright, so it says here for the sequences below, identify the common difference if possible and find the next term. So they either have a common difference or they do not have a common difference. Now remember, to find our common difference, we take our new term, subtract it from our previous term, and then we get some number. I think after that first example, you guys should be able to do this. So try it out really quickly, pause this video, try it out, and then press play to see if your answers match up with mine. Alright, so here's what I have. I have example 1, 2, and 3. After taking the new term, subtract it from the previous term, I got a positive 4, and I saw that the pattern continued, right? So my common difference, when I label that, is d is equal to 4, meaning that each new term is changing by 4. Now, for example 2, I took my new term, subtracted from the previous, I got a negative 3, and that pattern also followed, so it was negative 3 after each one. Therefore, my common difference was negative 3. Now, when I found a pattern here, and my common difference was d is equal to negative 3.75. Now, let's move to examples 4, 5, and 6. Now, I went out and go ahead and took 600 minus 200, and I got a positive 400. 1100 minus 600, a positive 500. 1700 minus 1100, and I got 600. Now these numbers should all be the same if we want to say there is a common difference. In this case, we have 4, 5, and 600. So there is no common difference. There is no common difference. Let's move on to 5 and 6. Alright, example 5. So remember, it's new term minus old term, new term minus old term. So this is a whole number, we're subtracting it from a fraction. Now remember, we can turn any fraction into a whole number by putting it over 1. And now for subtracting fractions, we need to make sure that they have a common denominator. So in this case, the common denominator is 4, so I need to make sure I multiply both sides times 4. Right, so what I really have here is going to be 8 over 4. 8 over 4, so let me erase this and put 8 over 4. This is actually equal to 8 over 4. Now it's going to be 8 over 4 minus 11 over 4. Since this is a smaller number, if I have a common difference, it's going to be a negative number. So from here to here, it's going to be a negative 3/4. And from 2 to 5, it's also a negative 3/4. And the pattern continues from here to here, and from here to here. So it's a negative 3/4, negative 3/4. Remember, you guys have calculators. You can plug fractions into your calculators to find out this here. And so the common difference in this case is going to be a negative 3/4. Alright, let's find the last one. From here to here. I think you guys can do that. I think it's going to be considered d is equal to a negative 18. Alright, the last thing I did not do, what it asks us to do, was to find the next possible term. So let's go ahead and list those out really quickly before I move on. Alright, so for example 1, my next possible term is a 36. For example 2, my next possible term is a 26. For example 3, my next possible term is a 6.8. Alright, for example 4, well, there is no common difference, so I can't list it. For example 5, my next number is going to be -1. And then for example 6, my next number is going to be a -139. Those are the next following possible terms. Geometric sequence, a sequence of numbers in which each term is equal to the previous term multiplied by a constant. This constant is called a common ratio. Now, to find our ratio, we take our new term divided by the previous term. So that's important to remember when moving on to these examples. Alright, for the sequence below, identify the common ratio, if possible, to find the next term. Now, if you go back to your notes, remember it says take the new term, put it over the previous term, and then simplify to find that number, right, to find your value. And then when you repeat that process for each one, the ratio should be the same. So let's go and do a few examples. So here's the process right here for example 7, right? We're trying to find the common ratio. So I took the new term, put it over the previous term, 6/2. Now when I simplified, I got a 3. Now I repeated that process for each one. So 18/6, 18/6. When I did that, I have 3, 54/18, 3. So after I did those 3, it seems like there is a common ratio. And then after 162. So in this case, my common ratio is 3 after I simplified. So this is a common ratio for 7. Now you're going to repeat this process for problems 8 through 12. I'm going to write down the answers, and then you guys check yours after you have tried it yourself. Alright, so here's the example for number 8. Remember new term over previous term. I got the same common number, the same common ratio, which is 1/4. Oops, actually these are not supposed to be D's. This represents the difference. These are all supposed to be R's. So let me go ahead and erase this really quickly. So the common ratio should be R is equal to those numbers, not D. So this should actually be, sorry guys, R is equal to 3, and this one should be R is equal to 1/4, common ratio. Alright, so here are the answers for 10, 11, and 12. Your common ratio here is going to be 2/3. For 11, your common ratio is going to be 1/4. And then for 12, there is no common ratio. Alright, so for these problems down here, we need to identify if there are arithmetic or geometric or neither. And then if they are geometric or arithmetic, we need to figure out what is the common difference or the common ratio. And then we need to find the next term. So here's what I would like you guys to do. Go ahead and try it yourself, and then pause the video and then play it. I'm just going to have the numbers written out. I'm going to have the answers written down, and you can check your work. Alright, here are the answers. So the first one, 13 is geometric. Common ratio is -5. Next value is 625. 14, there is none. It's neither. 15 is arithmetic. The common difference is 5, and the next value is 29. 16 is geometric. Common ratio is 2. The next value would be -32. 17 is arithmetic. The common difference is -1/4. The next value would be 6. And lastly would be geometric. The common ratio would be 0.2. The next value would be 0.0448. Alright, so that was your lesson over arithmetic and geometric sequences. Go ahead and complete your homework for me, please.